Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good day to you all. Today I would like to present my paper with the title Development of Back-end of a Rural Participation-Based Knowledge Management System of Smallholder Palm Plantations with the author Mr. Irman Hermadi, Andi Muhammad Hafidz, which is me, Mr. Auzi Asfarian, Miss Yani Nurhadryani, and Miss Nadya Farchana Fidaroina. The introduction of this paper. All palm is a plant which produces a variety of agricultural products such as palm oil. Because of the plant benefits, oil palm is popular among investors due to its high economic value. Because of its high demand and popularity, oil palm attracts the attention of smallholders to cultivate it independently. Consequently, smallholder plantations, or PR in this chart, came second as the largest area of the plantation based on ownership in Indonesia. 40.6% of the total area. However, despite its vast area, smallholder plantations have the lowest productivity amongst other plantations. The low productivity of smallholder plantation is due to the low use of fertilizers, low quality seeds, and poor production practices. These poor practices by the smallholders are because they had difficulty accessing the knowledge regarding the plantation practices, and still work independently without external assistance such as information and communication technology, or ICT. The existence of ICT can boost agricultural productivity through information and knowledge distributions by communicating into the smallholders farmers. Knowledge Management System, or KMS, is one of the ICT that can help farmers. KMS can provide farmers with access to knowledge regarding oil palm plantations. To suit the needs of smallholders, the approach that can be used in developing KMS is the approach of rural participations. Now on to method. In this study, we use the KMS LC method, or Knowledge Management Life Cycle, by Awad and Gaziri. The steps are evaluate existing infrastructure, form the knowledge management team, knowledge capture, design KMS blueprint, and verify and validate the KMS. In uh, this step consists of evaluating the process, knowledge, and infrastructure in oil palm plantations. We evaluate the existing infrastructure based on dimensions of knowledge management infrastructure by Becerra, Fernandez, and Sabrawal, which consisted of organization and culture, organization structure, information technology and infrastructure, common knowledge, and physical infrastructure. We carry out this stage with some literature studies and interview with an expert on oil palm plantations. In this step, we aim to identify the team members who will be involved in developing the KMS. The formation of knowledge management team members is based on Awad and Gaziri and is carried out by discussion with the research team. The required roles are knowledge developers, domain experts, and KMS developers. In this step, we aim to find out what knowledge exists and needed by farmers in oil palm plantations. According to Becerra, Fernandez, and Sabrawal, the source of knowledge exists in three locations, such as humans, artifacts, and organizational entities. We carry out this step by interviewing the experts, and the knowledge that has been captured will become knowledge stored in the system in the form of contents. The steps aim to design KMS blueprint based on the results and analysis of the previous stage. The design of KMS blueprint for back-end development consists of analyzing the functional requirements of the back-end scope of the system, designing the class diagram, and designing the KMS architectural layer based on Awad and Gaziri. This step is where we test the design of the KMS that has been made in previous stage. We carry out the verification by using integration testing to test the endpoints with the user interface. For the validation, we use the black box testing method to determine the functionality and the response of each endpoint. The verification and the validation steps will be repeated until both of them are considered successful. Now on to the results and discussions. The result and discussion for evaluating existing infrastructure are organizational culture. According to experts, farmers rarely receive counseling and training from extension agents, which usually come from local department. Even if farmers got some counseling training, most of the contents provided cannot be understood by the farmers. Contents are sometimes inaccurate, not suitable for the situation in the field, written in scientific language that is too difficult for farmers to understand, and not accompanied by appropriate pictures. Because of that, the farmers still tend to solve problems with their knowledge. Farmers are willing to learn, but there must be an example of practices, and that is why pictures are the most essential component in the counseling and training. Organization structure. Smallholder does not have an organizations unless there are cooperatives in the area. According to Tejelsma et al., there are three groups of smallholder based on the size of their area of plantations, which is small farmers, medium farmers, and large-scale farmers. For the small and medium farmers, they still manage their plantation by involving family members. For the large-scale farmers, some of them already dependent on farm laborers to do the work on their plantations. Information and technology infrastructure. According to Nadya et al., farmers already have a high ICT literacy on handheld devices such as smartphones, and they can use it with ease. But most of the farmers still use smartphones just for communication and social media. According to ICOSICA et al., their knowledge management is held using social media, such as a WhatsApp group, where farmers can communicate with extension agents. But knowledge management through social media still has its flaws, such as loss of knowledge of first time due to a considerable number of new message and spam vulnerabilities. Common knowledge. Farmers' knowledge are varies. Some farmers are experienced because they are former workers of oil pump companies, and some are just starting out and are still learning. Physical infrastructures. Access for vehicles such as bridges and roads are considered lacking. Farmer access to quality resources such as fertilizers and seeds is still difficult. Based on previous results, we can conclude that the knowledge of farmers is still lacking due to the lack of getting counseling and training. That makes them tend to rely more on the knowledge they have to solve a problem. Farmers are also willing to learn, but they need good examples and need to be encouraged such as training and counseling with understandable contents. According to Nadya et al., since farmers already have high ICT literacy on smartphones, it is recommended to develop a system based on smartphone as the primary tool. With that in mind, we put the main features of the KMS in mobile platform, such as creating, storing, and viewing contents. And to help farmers to understand, the contents of the KMS are divided into three types, which are articles that contain text images, video or audio so the smallholders can easily watch the examples of practices, and e-documents such as an electronic book that can be downloaded. The results of the discussion with the research team resulted in a team that involved knowledge developers, domain experts, and system developers. Knowledge developers responsible for dealing with knowledge from domain experts, identification of scope, knowledge capture, and coordinating teams in projects. Domain experts are the primary source of knowledge. KMS developers have the responsibility for the system development. The result of knowledge capture is gained from interview with the experts. According to the experts, there is some knowledge that smallholder needs to cultivate, or pump, and where some of it can be found. The result of knowledge captured from the expert can be seen in the slide and or the paper. The capturing process of the knowledge can be done in interview, video or audio recording, literature studies, or experts can document their knowledge in the KMS. These pieces of knowledge will be stored in KMS in the form of contents. From the result of discussion and analysis, the functional requirement of KMS can be seen in slide and the paper manuscript as well. These functional requirements can help us developers to determine the function and constraint on KMS. The class diagram we create is based on use case diagrams made by the front-end developers. The domain model class diagram for the KMS is shown in the slide. The KMS architecture that we made can be seen in the slide and or the paper. The user interface layer is developed by the front-end developer, while the rest of the layers, that is authentication, filtering, application, internet, physical, and repositories are developed by the back-end developer. For the implementation of the back-end of the KMS, we use Laravel 7 framework and MySQL for database management. The user interface layer is on top of the architectural layers because it is the first part of the system that user use. The KMS is designed to be implemented on web and mobile platforms. This layer is developed by the front-end developers. The authentication layer. This layer manages the security of the KMS using user authentication. There are 5 access rights or roles in this KMS, which is farmers, experts, validators, admins, and super admins. To authenticate each user and check their authenticity, we use JSON Web Token or JWT and middlebar on each endpoint. The middlebar will ensure that the only user with relevant roles and already registered can access the content of the endpoint. The collaborative agent and filtering layer. This layer manages the distribution of news such as notification as well as categorization and content search. The application layer. This layer is part of the function of the model that has been created before. This layer regulates the receiving and giving of the data to other layers. To exchange data, the REST API is used with JavaScript Object Notation or JSON for the response format. The transport on Internet layer. The transportation of the data in KMS is using the Internet. This layer serves to distribute data such as documents and files. This layer allows the system to be accessed as long as the user can be accessed in the Internet. The physical layer. This layer consists of physical devices such as cables, storage devices, and Internet modems. We store the KMS on a live server so that it can be accessed via Internet. Since KMS is a hosting service provider, all the physical devices need to have been provided. The last layer, the repositories layer. This layer is part of the database in the system. Database settings are done using MySQL technology. The tables in the database are created based on each class from the previously created class diagrams. Next is verification and validation. This test is conducted. Verification test is conducted to determine whether the endpoints are successfully integrated and in accordance with the user interface created by the front-end team. Endpoint testing is said to be successful if the front-end team has successfully sent a request through the endpoints and received a response from the endpoints. Some of the integration testing results can be seen in slide and/or paper. The validation testing. We carry out the validation of the KMS using black box testing method. This test is carried out locally by using Postman program for sending a request to the endpoint and receive the response. From the response, we can determine if the endpoint is working or not by giving the correct status code based on 4 scenarios that can be seen in the slide and/or paper. Each scenarios have their own status code. The status code explanation can be seen in the slide and/or the paper. Result of black box testing shows that all the endpoints successfully return the correct response based on their scenarios, and some of it can be seen in the slides and/or the paper. The limitation of the study. Due to COVID-19 pandemic, this study is limited to the literature studies and interview with experts. Therefore, the results of this research will not be as accurate with the actual condition of the plantations, and there are many assumptions based on the results from the literature studies. There is also a feature in the system that has not yet been implemented, which is the notification feature due to the development of the front-end system had not been completed. The conclusions. Based on the study results, we had built a backend for oil palm plantations. KMS based on rural participation using KMS LC method. From infrastructure evaluation, we can determine that some of smallholders have limited knowledge and the existing of KMS can help them to gain knowledge and boost productions. The fourth team consists of knowledge developers, domain experts, and system developers. Knowledge capture shows that knowledge needed in the plantation are mostly texted knowledge. The backend application is built in the Raffles framework and MySQL, with all of the endpoints were successfully tested. The existence of the KMS can benefit the smallholder and other farmer in gaining, exploring, and sharing knowledge about oil palm plantations, and hopefully able to boost their productions. At last, acknowledgement. We want to thank Directorate of Research and Community Service, Directorate General of Research and Technology Strengthening and Development, and Ministry of Research, Technology, and Higher Education for funding this research through the Penelitian Dasar Unggulan Perguruan Tinggi 2020 or Basic Research of Higher Education Excellence 2020, namely Smallholder Palm Oil Knowledge Management System based on rural participatory approach. Here are the references that is used for the slides. And that's the end of the presentations. Thank you for your attention.